So you change f of x to y, and then you switch x and y. X is equal to 1 minus 2y over 1 plus y. Now we want to solve for y. So I'm going to multiply both sides by 1 plus y. So I have x times 1 plus y equals 1 minus 2y. Distribute the x plus xy equals 1 minus 2y. Now I want to get all the y's on one side, all the x's on the other. So I'm going to subtract 1 to move the 1 from the right to the left, and I'm going to subtract xy, moving all the y's to the right, everything else to the left. Now I want y by itself, so I'm going to factor out a y. And I have negative x minus 2. So now if I want to get y by itself, y is equal to x minus 1 over negative x minus 2. Now, you can see that particular one there, or what you could do is factor out a negative from the denominator. So if I factor out with the denominator, I'm changing the signs in the numerator. I can make this negative x plus 1, or it could be 1 minus x. In either case, I took a negative out of the denominator, and then I put the negative in the numerator. So 1 minus x over x plus 2. Again, this is a part 1, so some variation or form of the inverse is what you're going to be looking for. Change all of the signs in the second polynomial. X to the fourth cancels out, and x to the third plus x to the third is 2x to the third plus 4x squared. X squared goes into 2x to the third 2x times. 2x times x squared is 2x cubed, and 2x times x is negative 2x squared. Change the signs of the second polynomial. The x cubes cancel out. 4x squared plus 2x squared is 6x squared. Bring down the 3x. 6x squared divided by x squared is 6. So you have 6x squared minus 6x. Change the signs of the second polynomial. A positive 6x and a negative 3x is 3x minus 19. Now x squared does not go into x. So this is your remainder. So it's a remainder of 3x minus 19 over the divisor. So as a multiple choice question, you're looking for x squared plus 2x plus 6 plus, and then 3x minus 19 over the divisor x squared minus x. So I graph 0, 2 is the y-intercept. I graph the zeros as negative square root of 2, positive 1/2, positive square root of 2. And I know the shape of this graph from the leading coefficient test. The hardest part here was the factor by grouping. That was probably the hardest part of this. This whole question is worth 12 points, so it's broken down into different segments. So factor the numerator, factor the denominator, no common factors, so we're just setting the factors of the denominator equal to 0 to give you the vertical asymptotes. Now let's take a look at another part 1 question, and that's on the horizontal asymptotes. So let's review what you need to know for the asymptotes. We have the exponent in the numerator is n, and the exponent in the denominator is n. When n is less than m, that is the coefficient in the numerator is less than the coefficient of the denominator, we have a horizontal asymptote of y equals 0. When we have the exponents equal, n is equal to m, then we get an equation, y equals the coefficient of the numerator over the coefficient of the denominator. And when we have n is greater than m, we don't have one. So let me pick a couple of problems here that we can do. Okay, the first one. The exponent for the numerator is 1. The exponent of the denominator is 1. So n equals m. So now we're looking at the coefficients. The coefficient of each one of them is 1. So we're just getting a horizontal asymptote of x equals 1. Oh, that's boring. Let me change the problem a little bit, make it more interesting here. Let's make it an x squared plus 5. Let's change that. All right, now the exponent in the numerator is 1. The exponent in the denominator is 2. So n is less than m. That means we're getting y is equal to 0. We have this situation here. 1 less than 2. Here we have numerator and denominator same exponent of 1. Therefore, we have y is equal to the coefficient of the numerator, the variable in the numerator, the coefficient of the variable in the denominator. And the next one, we have n in the numerator it's 2, the denominator is 1, so here we don't have a horizontal asymptote.